afternoon to all, and welcome to Anu Krishna online chemistry classes. And today we'll discuss about a brief concept is matter pure. And most of the substances in our day-to-day life, we come across so many substances, and all they are examples of the mixtures. All they are examples of the mixtures. And the mixtures are made up of the two or more pure components or the two or more pure substances. Okay, now then, for example, when you take in the air is a combination of the several materials. For example, in the air, nitrogen gas is present, oxygen is present, carbon dioxide present, dust particles are present, and a small amount of noble gas is also present. Okay, that's why air is called as a mixture. And whenever taking the water we drink, it is also example of the mixture, because the water is consist of the certain dissolved salts, or the purified water is consist of the some minerals. That's what I said, the water is also example of the mixture. Next, if you take the blood is the combination of the several type of substances. The blood consists of the RBC, red blood cells, and WBC, white blood cells, blood platelets. Next, plasma, serum, hemoglobin, iron content. These all are the different materials present in the blood. That's why blood is also example of the mixture. And then when you drink the certain type of juices, apple juice, sugar, apple juice, banana, or any Mosambi. These are all the examples of, these are also examples of the mixtures. Okay. Now I will discuss about the first of all, what is the definition of mixture, and how many types of mixtures are there, and what are the different examples of mixtures. What is the definition of mixture? A mixture is defined as it is a combination of two or more substances. It is a combination of two or more substances, and they are present in any ratio. The two or more components are present in any ratio, and they are physically reacted but not chemically. Just they are physically reacted but not chemically. Then whatever the new substance is formed, then it is called as a mixture. Okay. Mixture also one type of substance, but these substances can formed by the combination of two or more substances. Then they are present in the any ratio, and they are physically reacted but not chemically. That substance is called as a mixture. When you take it the soil, the soil is example of the mixture. Sand particles are present, iron fillings are present. Okay, now some minerals also present. And otherwise, I will take it the seawater. The seawater is also example of the mixture. Water is present, dissolved salts are present, and then ash particles are present. Okay, and sand particles also present. So that is also example of mixture. And whatever the ratio of these components, they are not present in the particular ratio. They are present in any ratio. They are present in any ratio. That's why that substance is called as a mixture. Okay. Then mixture, it is defined as it is a substance formed by the combination of two or more substances present in any ratio, and they are physically reacted but not chemically, but not chemically. Okay. So what is mean by physical contact and what is mean by chemical contact? Okay, now physical contact and then chemical contact. Let me will discuss. For example, and just now I told the soil is example of the mixture. Soil is example of the mixture. Here in the soil, the sand particles are present, and then for example, iron fillings also available. Iron fillings also available. And iron is individually attracted by magnets, and sand is insoluble in the water. Iron is attracted by magnet. Sand is insoluble in the water. Before the mixing, individually the iron property attracting magnet and sand is insoluble in water. Then the sand and iron is both crushing of iron particles and then sand particles. Both are crushed with the help of any machine or any device, or we will use the force. After the crushing of sand and iron particles, leave it the substance, and again I will take the magnet and then rubbing on the crushed mixture. Whatever the mixture we crushed, in that what happened, I will rub the again any magnet. Then again what happened, whatever the substance, whatever the iron fillings present in the crushed mixture, then again they are attracted by the magnet, and that crushed mixture I am taken in the water, crushed mixture taken in the vessel and then pour the water. Then the sand particles are insoluble in water, then iron is present in the, leave it in the vessel. That iron particles are attracted by magnet. Okay. Before the mixing and after the mixing, their properties are not changed. The properties of the substances are not changed. Then the process is called as a physical contact. If they are chemically reacted, what happened? We are getting the one more type of products. Okay, now the formed new substance cannot attracted by magnet and maybe it is soluble in the water. That's what I said. So physically reacted but not a chemically. Okay, soil is the best example, and otherwise I will take the one more thing. I will take the vessel, and I will take the one more vessel. In this vessel, I will take the certain quantity of water. Here also I will take the certain quantity of water. Certain quantity of water. In the first vessel case, I am adding a small amount of salt. A small amount of salt. And second vessel case, I am adding the sand particles. Second vessel case, I am adding the sand particles. Whenever the salt is added to the water, the salt is completely soluble in the water, and the sand is added to the water. The sand is insoluble in the water. Sand is insoluble in the water. And before adding the salt, the water is available in the liquid state. The salt has a salty taste. Salt has a salty taste, and then water is present in the liquid taste. And then the sand is present in the solid state, and then water is present in the liquid state, and sand is insoluble in the water. So after adding the sand into the water, the sand is just settled down at the bottom of the vessel. The sand is just settled down at the bottom, but the salt is soluble in the water. Okay. Here, before adding, the taste of salt is salty, and then water is available in the liquid state. And before adding, the sand is available in the solid state, and after adding the water also, the sand is available in the solid state. Okay. Before the mixing and after the mixing, their properties are not changes. Then the respective substances are called as a mixtures. Salt water, sugar water. Instead of salt, I am taking the sugar. Instead of salt, I'm taking the sugar. The sugar is sweet in taste. Then water is available in the liquid state. Whenever sugar dissolves in the water also, the sugar has a sweet in taste. The water is present in the liquid state. The taste of the sugar doesn't changes. The water physical state also doesn't changes. Just they are physically reacted, but not a chemical. Okay. That property only we are called as a physical contact and then chemical contact. In the mixture, the two components are just physically contact with each other, but not a chemically. That's why it is called as a mixture. And again, mixtures are how many types? The mixtures are of two types. What are they? Homogeneous mixture and then heterogeneous mixture. Homogeneous and heterogeneous. How we can differentiate which is a homogeneous and which is a heterogeneous? Okay. Here, first case, whenever the salt is added to the water, the salt is completely soluble in the water. The entire water, we are getting the salty taste. Entire water, we are getting the salty taste. The salt is uniformly distributed in the water. The salt is uniformly distributed in the water. Whereas in the case of second case, the sand is added to the water, the sand is settled down at the bottom. The sand content is more or high in the bottom of the vessel. At the surface, at the middle layer, the sand content is maximum 0 or very less. Here, the sand is not uniformly distributed. Here, the salt is uniformly distributed. Here also, the sugar uniformly distributed in the entire water. Okay. Based on these criteria, the mixtures are of two types. The distribution of components are takes place uniformly or not. Component is nothing but the substances which are used to make a mixture. Okay. Mixtures are of two types. One is a homogeneous mixture. Homogeneous mixture. In a mixture, the components uniformly distributed. Is called homogeneous mixture. Homogeneous mixture. What are the examples of homogeneous mixtures? Salt water. Next, sugar water. Air. Etc. These are the homogeneous mixtures. Urea water. These are also examples of the homogeneous mixtures. Next, heterogeneous mixtures. Heterogeneous mixture. Heterogeneous mixture is nothing but in a particular mixture, the components or the substances which are not uniformly distributed. Then they are called as a heterogeneous mixtures. Okay. The components uniformly not distributed is called heterogeneous mixture. Heterogeneous mixture. Examples: sand in water, soil, oil in water, etc. They are examples of the heterogeneous mixtures. Oil in water. Okay. So these are the different type of mixtures: homogeneous and then heterogeneous. Next, few more examples. 24 carats gold. It is element. 24 carats gold is an element. 22 carats gold is a mixture. Because in 22 carats gold, 22 grams of gold is added and then 2 grams of copper is added. Either copper or silver. Copper or silver is added. That's why 24 carats gold is a element, 22 carats gold is a mixture. Okay. Best example that also. Okay. Stainless steel. There are also examples of the mixtures. Like that we will explain. Please subscribe the channel and share the video. Thank you.
Wait, see, pack it smooth, Danny, set a boat, candy.